Okay. So this is similar to a problem from homework 7. You're given some table and some common queries that will happen, and you want to pick an index that will index or multiple indexes that will speed up those queries. Pick the minimal set. So find all students who earned a B and find all students who earned an A in calculus. And notice that the primary key is just student ID. So that's the only index we have, and that has nothing to do with either of these queries, at least the filter part of these queries. So find all students who earned a B. That kind of implies we're going to want something involving grade. And then find all students who earned an A in calculus. So that implies we want something involving class name. So we could do, put an index on grade. That'll handle the first query. Then what's an index that'll make the second query fast?
Grade, class.
Okay, so we could do grade, class name. We could also do the opposite order for the second query. That's basically an AND. You want class name equals calculus and grade equals A. That's what that filter would turn into. But turns out if we just do this, then it supports both queries. If we put grade first, then it automatically supports searching just by grade. And if we put class name second, doesn't matter what the order is, it supports the AND query. Okay? So that's the minimal set of indexes that will speed up these queries. So order matters when you're dealing with multi-column index. And do stop me at any time with questions. That's kind of the point. Okay? So the plan generator, we're given a query and a bunch of potential plans for that query. Which one is it going to pick? So this is one way of writing plans. It's just in relational algebra. Another way is those diagrams we saw where you have like a project going into a select or whatever. But we're just dealing with relational algebra. So for this query, this is the chess database. It doesn't really matter because we just have column names here. First of all, are all of these valid plans? So let's look at them. So select date from events where name equals X and site equals Y. Okay, so select, SQL select turns into relational algebra project. So there's the pick out the date column. And then we have, so filter first down, go through all the events and find the events where site equals Y to get some sub-relation. Then out of that sub-relation, filter down where all of the name equals X, and then project out the date. Okay, is that valid? Yeah? No? Yes, that's valid. Okay, project out the date from all events, then take only those ones where name equals X, and then only those ones where site equals Y. Is that valid? No, because we don't have names and sites anymore after projecting out only the date. Okay, so let's look at this third one. Go through all events and filter down by where name equals X and site equals Y, and then project out the date from those. Valid? Yeah. So these two, the first one and the third one, are both valid, but which one is better? Which one is going to require less work?
I would say the third one, because for the first one, we'll have to go through the whole list and find where all the sites equal Y, and then from that list, we'll have to iterate through again and find where all the...
Yep, so the first one, you'd have to go through every event, and then you'd have to go through every filtered event. The second one, you're going through every event anyway, you might as well look at both columns at the same time to do the AND. Yeah, so it would pick this one. Okay. So more plan generation, but this time more related to a join instead of just a simple filter. So select star from students, natural join, enrolled. So first of all, what is that natural join going to do? These are the columns they have in common. So that's like a join on SID equals SID. And this time we're not looking at like relational algebra plans. We want to know for the join, it's going to do a nested loop join. Which one is the outer loop and which one is the inner loop? So remember, R is the outer loop, S is the inner loop. So it could do it either way. Which one will become R and which one will become S? And we're given number of rows in enrolled is greater than number of rows in students. And then we're told to infer the number of pages. The best we can do there is assume that, well, let's see. Number of enrolled is greater than number of students. If we just assume that number of pages for enrolled is greater than number of pages for students, then that's a reasonable explanation. As long as whatever we picked, as long as we explained it, then that would be valid. So I might do that, or I might tell you the number of pages, or I might tell you the exact sizes of these columns and have you figure it out. But let's assume that number of pages in enrolled is greater than number of pages in students. And we don't get to add any indexes. So what's the plan generator going to do here? What's R, what's S? Let's go over how does it pick this? If there are no indexes it can use to make the join faster, which one does it use as the inner loop? Students, why? Because it's smaller, yes. So if there were no indexes at all, it would use students as the inner one. If there was an index on only one of them, an index that helps look up a foreign key from one of them, then it will use that as the inner one. If there's an index that helps on both of them, then which one will it use? Still students? So if there's an index on both relations, so it can quickly look up a key on both relations, which one will it use?
I don't know.
You do know.
I do.
Yes, and it's based on the rest of the information we have.
If the target one fits in the cache, wouldn't it be that one?
So yes, it will. I mean, you do have to think about which one's going to fit in memory better, and that's why by default it's going to pick the smaller one as the inner one. If there are no indexes that help. If there's an index that helps, then it doesn't really matter what the size is. For an index on both of them, I can quickly look up anything from enrolled given an SID or anything from students given an SID. It still has to loop over one of them. Which one will it put on the loop and which one will it use the index for?
Would
use the smaller one to go through and the bigger one to look the index up?
Yes, it would use the smaller one as the outer loop, the bigger one as the inner, because an index on a bigger set is going to provide more benefit than an index on a smaller set. So it would be, so first of all, let's answer that question though. Do we have an index that helps on both? Yeah, if students is the outer loop, then we can take the SID here and look up an SID out of that index. If enrolled is the outer loop, then we can take an SID here and look up an SID out of that index. So R is going to be the smaller one. S is going to be enrolled, the bigger one. And that's simply because the logarithmic reduction on a larger quantity gives you more benefit than the logarithmic reduction on a smaller quantity.
So if enrolled didn't have SID, would they be switched?
So if enrolled did not have SID in here, or maybe if these two things were swapped, then it would not have a choice, because that index would not help look up an SID. There is an index on them because of the primary key.
Oh.
Students, for example, pick one page, would you still put it on the outside?
So if students only occupied one page, would you still put it on the outside? That's where it kind of gets tricky to determine. My guess is it would put it on the inside. Actually, it's hard to say though. Depends on how much bigger enrolled is than students.
If they didn't have a key in common, like what would happen?
If they didn't have a key in common, then natural join wouldn't work. Or if they didn't have a column in common, then natural join wouldn't work. Okay, here's another one. So that was students joined with enrolled. This is enrolled joined with courses. We have the same enrolled table, and courses is just some course ID plus a course name or whatever. And it's a similar query. It's just a natural join. Number of enrolled is greater than number of courses. Number of pages in enrolled is greater than number of pages in courses. So same rules apply. If there's no index that helps, then it will put the smaller one on the inside. If there's one index that helps, it'll put that one on the inside. If there are two indexes that will help, it puts the bigger one on the inside. So what do we have here? So enrolled would go on the inside, because which case is that? 0 indexes that help, 1 or 2?
Oh, yeah.
So yeah, this is the difference here is this index does not help with that natural join. If I loop over courses and take a CID and try to look up a CID using that index, it doesn't work because it's not the first column. So what that means is there is only one index that helps here. So we have to do R equals enrolled and S equals courses. Because if we loop through every enrolled, we'll have some CID. We can use that to quickly look up a course. Okay. Any questions on this RS stuff?
So the only time where neither would have
an index and be connected when it's not primary. That's correct.
The only time where neither of them would have an index is if you're not joining based on a primary key.
Yeah. It seems like you always have an index.
You do always have an index on the primary key. So I'll say sort of to that, because you can have a multi-column primary key, like in the case here, and it involves one of the right columns, but it's not in the right order. Does that make sense? Okay. So we have another one of these that's sort of along these lines of like indexes and joins on the chess database. This is like a simplified version of it. So I'll show you the problem on the next slide, but I want to just kind of remind you a little bit what's going on here. So white player and black player are both referring to a player's PID. Okay. Games have a just some GID key, but it also has EID, which refers to events as a foreign key. So games has a lot of foreign keys pointing out to other tables. Now the question we have is, this is actually one we did in class, but we'll go over more in detail, like why it picks, why you should pick the index that you should. So we're given this query. We want select whatever from players join games, natural join events, where PID equals white player, and then just some straight date filter. So this date filter is not involved in the join. It's not saying like join on this condition. That's just an additional filter after the joins or before, whatever it decides to pick. The natural join part, games natural join events, is going to use this. We can't do a natural join between games and players because the column names don't match. We have two of them. We have white and black. But the join condition we're doing is where white is equal to PID. Okay. And then we have some existing indexes, just the primary keys. Let me pause for a second and say, if these are the only indexes, and I've said that these are actually foreign keys, that doesn't quite add up to in reality. If these were foreign keys, then there would be indexes on those columns in MySQL. So actually, no, let's just say these are not foreign keys, but we will be using them as foreign keys. They are going to refer to another column, but we didn't actually create the foreign keys in the table. Okay, so we have the primary keys of each, and we're saying games is greater than players is greater than events. So we can make up some numbers here. Let's say there are like 10,000 games, 7,000 players, 5,000 events. And then our task is to pick one index to add that will speed up this query the most. So let's think about this a bit. What is it going to do if we don't add any indexes? What's it going to do right now?
I'm guessing it'll start by looping through games, and then each game will, I guess, fantasy, it'll list the relevant events, see if it is correct. If it's not the one that is correct, then it'll start. And then it'll use white player loop through white player PID.
Okay, so it's going to start, let's say, with games as the outer loop. And then maybe loop through events, then players. So loop through every game, and then loop through every event, and then loop through every player. So we get roughly like 10K games, and then can we use any index for that second part, for that inner middle loop? Can we? Yeah. So a game has an EID, and it can use that in this index. So we'd get roughly 10K, roughly 1. And then what about players? How many would we have to loop through there to find the matching player?
Also, if you want, because we should use
Yep.
ID for white player.
Yep. So we have white player. We can use that to quickly look up using this primary index. Okay? So you get roughly 10K times 1 times 1. That times 1 is actually a tree search, but we'll call it 1. It's going to look at roughly 1 row. Okay. Now, let's look at possible indexes that might help this. An obvious thing to try is to try to make this where filter faster. So if we put an index on date, that doesn't help with the join condition, but what it does is lets us trim down one of the tables before joining. So we could then do events, where we have roughly 1 of them. It'll be a few, however many events were on that date. We'll call it 1. And then what? So if we have those few events as the outer loop, what's going to be the middle loop? If we put games there, if we have an event, can we find corresponding games that happened at that event quickly?
No.
No, why not?
There is no index on EID in game.
Yeah, because we can't go this way. There's no index on EID in games. We can go this way quickly. We cannot go the other way quickly. So that's going to end up being roughly 10K games. And then we can quickly find the 1 player that was the white player of those games. Okay. So it seems like basically what we have to do is get rid of that 10K. So even adding an index on date didn't really help here because we still have 1 loop around every single game. Okay, I have another page here kind of just for more room. So things we tried were, well, no indexes at all, index on date. Let's try putting an index on games.whiteplayer. Okay, so that'll let us start with a white player, start with a player, and quickly go find any games where that player played as white. So we could loop over all players and get roughly 7K, just as the outer loop, because I said there are 7K players. Okay, then we could find games where that player played as white, call that 1, and then we could loop over the events. Since a game has an EID and an event has primary key EID, call that 1. So that's better. You have a 7K loop, 7 times 1 times 1 instead of 10K times 1 times 1. And then finally, the other thing to try to make these joins faster is an index on games.eid. So that, as I said, right now we can take a game and quickly look up the event that it occurred in. that index, if we add an index on games.eid, then that would let us go the other way. So let's see what that does for the numbers. Okay, now we can start the outer loop with events, which I said is roughly 5K. Taking any event, we can immediately find all games that occurred using that index. So we'll call that 1. And then we can find, given a game, we can find the player since we have a white PID and there's already a key on player ID. So we end up with, some large several thousand times 1 in each case, and this is the smallest that we can do. Yeah.
If you were able to add one more index and third index on date, then that would make it really fast.
If you were allowed to add another index, then an index on date would make it faster. Yes. Okay. So there are kind of more subtle rules involved when, does this index help me going from A to B, or does it help me going from B to A? And how does that change the order of the loops that it's going to pick? And when I say loops, the most default basic thing it can do is for each A, for each R, for each S, for each T. When there's an index involved, I still kind of say loop, but it's no longer actually a loop, it's an index lookup, which becomes logarithmic instead of linear. Okay. These are, by the way, in no particular order. I'm just kind of going through some things that we've talked about since the midterm. So JSON and link. So we have, let's say, some controller, and we need to return information to some view. And the view wants it formatted in a specific way. It wants TTL for the title. It wants writer for the author, and something called copies, which is an array of serial numbers. Okay, and we're given some. What we're given is some ISBN. So we're gonna find one book. We want to know the title, author, and serial numbers for that book. So I've got part of the query started. So var books query equals from t in database.titles, where t.isbn equals x. That's whatever, some ISBN. Select something. So that's what we have to fill in. So since db.titles probably has columns named exactly as they are in the database, so title and author, we want TTL and writer. So we'll do select new. TTL equals t.title. This is all pretty straightforward at first. Writer equals t.author. So this is just kind of getting to the point of we can use these dynamic types in C# to just make a type on the fly with whatever names we want. So we'll use names that match what the view wants. And then copies. And then this is where it starts to get a little more interesting, where we can use link to, so what we need is copies needs to be an array. So there's not really an analogous query in SQL where you get like a single column, and then an array of things for the third column, third value. So what do we do here? How do we get the array of serial numbers for that book? Remember, the library has a table called inventory, which has ISBN and serial number. The ISBN is going to match something out of the titles table. So we could do some kind of nested query in here, where we do like select, or sorry, we'll need from first. We'll call it, I don't know, C in database.inventory, where c.isbn equals x, select c.serial. Okay, that works because we know we're only dealing with one book. But there is a better way to do it. So I'll kind of just put a little box around that and write another option. Copies equals from, I'll use the same variable, from C in, and then this is where the scaffolding gives us kind of like automatic linkage between tables where there are foreign keys. So we can do from C in t.inventory. So T is this titles thing. Every title has a linkage to the inventory table, and it's going to be a set of inventory items.
So when the table scaffold, is the default name for that variable just going to be the name of the other table?
Yes, the default name for that variable is the name of the other table. We're not quite done here, though. We have copies equals, right now it's an array of full inventory tuples. So we just need to do select c.serial. And then that can finally close up the whole thing that we are selecting. And kind of running out of room, but after that, then we still need to return the JSON. All this is currently is an IE numerable. So we would return JSON books query dot first. Because we are assuming that there is exactly one book with that ISBN. So we're returning one object where that object has a TTO, a writer, plus an array of serials. Perhaps a better thing to do here would be first or default. That way it wouldn't just crash if there was no book with that ISBN. It would return null instead of crashing. Okay. Then, continuing that, give an example of a JSON string returned by the code. So we would have something like a string, so I'm just going to put it in quotes. JSON objects start with curly braces, and then we would have TTL, colon, some title, comma, writer, colon, some writer, some author, and then copies would be an array of just unsigned ints. So 1 and 2. Okay. Yep.
Question about the keys. So I've seen some JSON specifies like TTL string, colon, whatever, and then writer would have, so like TTL and writer would have quotes around them, and then colon. Is there any difference?
Oh, so quotes here.
Yeah. I think it's both valid.
For our purposes, it doesn't matter. Anything else on this? Yeah.
What happens if we do a dot to array after the conflict?
What happens if you did to array right here, So yeah, that's another option, is we could do books query.toArray. If we returned that, then this whole JSON string would look like this. And then, yeah, if we returned .toArray at 0, then that would go back to what we had before. So two different ways of doing that. First or default is the best way of doing that, because then it doesn't crash. You automatically either get the object or null. You don't get an index out of bounds exception or anything like that. Okay, transactions. So we have some controller, and it has to return the correct number of patrons at the time when the controller was invoked. And all it is so you write some query. I don't even have it here, but you write some link query that's get all patrons. So it's just going to be like select star from db.patrons. And then a C# statement, return query1.count. So basically what the problem is saying is that at the moment we when we kind of have this query versus when we return, it needs to be consistent in the number of patrons that it returns. Do we need a transaction? Turns out this query doesn't actually do anything at all until we use it right here. So just declaring the query like that is just saying, here's some link query. And then actually using some information out of it, that's when it gets compiled to SQL and executed. So if the query turns into something like select star from patrons, that's a single SQL command, and it's going to be executed as a transaction, as all single SQL commands are. So there is no possibility for a race here. So we do not need a transaction. Okay, about this one. So we have some other query where patrons must always have greater than or equal to 1 phone number. There's some web server running where you can go in and remove a phone number from a patron. And the possible problem here is, what if there are two browsers connected to the web server, both trying to remove a number from the same patron? So query 1, get all phones for the patron if the count is equal to 1, meaning if I tried to remove 1, it would go down to 0 and violate that rule. Have to always have at least 1. Okay, so I return some error if that's the case. Otherwise, I remove that phone number and then save changes. Do we need a transaction here? Yes. You could have, say, Firefox come in and get to this point, pass the check, saying, okay, there's more than 1 phone number. And then you could have Chrome, or just another Firefox, or whatever, also get past that check, because the other process or the other thread serving Firefox has not actually removed anything yet. So they both make it past the check, and that's the race. And then they would both remove a phone number and then save changes, and you'd end up with 0 phone numbers. So what we need is something like start the transaction here, roll back the transaction here before returning. So you need to add curly braces. And then commit here. What kind of isolation level would we need on this transaction to make this work? So first of all, let me just ask, is this a mutex?
No.
No. Even wrapping this around start transaction and commit, two clients could still enter this code and start doing things at the same time. It's not a mutex, but we can get the desired behavior, but what isolation level do we need on the transaction? Anyone remember the name of it? So there's read committed, there's read uncommitted, there's repeatable read, and there's serializable. Anyone remember? So what we'll need is serializable. That's the only one that will actually, if one transaction has read something, that will prevent any other transaction from writing something, or vice versa. And we'll get to some examples involving isolation levels in a minute.
So you said that serializable is the slowest level.
Serializable is the slowest and, yeah, so kind of like most, what's the word? The most strict. Yeah.
Like, can we turn off serializable after we're done with the transaction?
Yes, you can turn off serializable after this one transaction. Okay, one more. So we have this kind of made-up query. I don't know what this query would be used for, but just for the purpose of an example, let's say what we want is at some snapshot, at some point in time, we want to know the number of patrons and the number of books, but only if there are some patrons in the database. So if there are 0, then we should return an error. If there are any patrons, then we should return exactly the number of patrons and books at that time when we determined there were some patrons. So do we need a transaction? I have like read-only queries this time. I don't have a deletion, like a read followed by a delete. I have a read followed by a read. Do we need a transaction to make this work?
I think yes.
Yes, because what we're not showing here is there might be some other controller deleting a patron. So it could come in, say, at this point, and delete a patron after you've already passed the check. So you would do start, roll back, and then the way this is written, since I'm returning right here, this is automatically, as soon as it hits, after this return, it's automatically going to commit. But you could rewrite this in such a way that you kind of save these P and B values, then commit, then return the result. Question?
If the return didn't ask for query one, that count?
If the return didn't ask for query1.count, would you need a transaction? Yes, based on the way this problem is defined, it's saying it should only ever return any count if there are 0 patrons.
If there are 0 patrons at that time, then the books aren't being modified. Okay.
If there are 0 patrons at the time and the books are not being modified, what if the patrons are being modified? Then we would say, okay, there are 0 patrons. Then suddenly there's a patron. Then we return the number of books. And we have some books returned even though there are more than 0 patrons. It's kind of a weird example, totally made up, just to make an example. Okay. So I want to get to more, so let's shorten our break. Let's do a 3-minute break. We covered this. You haven't really done any homework involving them, but this is kind of what I was just talking about. What isolation level would we need to make that transaction do what we want? So let's go through the various isolation levels. And the way to read these is, so I have 2 sessions both running some transaction, and time is going down, that's when the session attempts to issue that command. So if they're both at on the same line, that means they issue that command at the same time. If one of them is above the other, that means it attempts to issue before the other. Okay. So we have, and we want to know what is the result from session 2. So session 2 is going to be doing some selects. Basically, we want, like, what's the result of those selects? And the first one is isolation level read uncommitted. So the select count star is going to give us a 5. This first one. Then we have insert into X, insert something. We'll say these inserts are always going to be one row. So session 1 will insert something. Session 2 does another select count. And read uncommitted means exactly that. It's going to give us a 6, even though session 1 eventually goes and rolls back, and there are never actually 6 things in the table. But we get this inconsistency here where session 2 thinks that there are 6 things in the table for a brief time. If you were to then do another select here, you would get back to 5. Okay? Yep. Question? Yeah, this commit doesn't really do anything. Okay. So here we have, the only difference is session 1 is committing now instead of rolling back, and we have read committed instead of read uncommitted. So this select will give us a 5. This will do its insert kind of in its own isolated world. Select will give us another 5, because basically the way that read uncommitted works, or sorry, read committed works, is this will run within its own sandbox unless there's a commit that happens before that select. But the way this time diagram is showing it, the commit does not happen before the select. So we get a 5 followed by a 5. Yeah.
So session 2 didn't do selection. Session 2 just did insertion as well. Like, would we need transactions?
If session 2 is also just doing inserts, then all of them would just happen in whatever order they happen. There might be some conflicts at the time when you commit, if they both tried to insert the same row or a conflicting key or something like that.
Sorry, so we would need transactions, or should we still,
Would you need transactions or not? It depends on if you think there's going to be conflicting inserts here. Yeah.
So if they both commit and they both try to insert the same primary key, the database picks an arbitrary one to commit, right?
The database picks one to commit, yes.
Okay.
It's usually the one that tried to insert first.
So we can't count on that?
Yeah.
Okay.
Okay, here is also read committed, but I've reordered the statements a little bit. Basically, I've just moved these up in time. So select count is going to give us a 5. Insert, then commit. So now that insert is going to be visible by the time that select happens, and we'll get a 6 because it's read committed. So if that commit happens before the second select, then we get 2 different numbers out of these selects. Okay. Here's repeatable read. So the way this works is it puts both of them really, but this is the only one doing any reads. It puts that transaction into a completely isolated sandbox, like a snapshot, where anything that it reads is consistent with the time when the transaction was started. So no matter what is happening over here, we are going to get 5 and 5, even though there is technically a commit before that select. And that's repeatable read is, it's well named. That means you will see the same value if you do the same read. So the difference between this read committed and repeatable read is this is still this is called a read like an inconsistency. You can read the same, you can do the same select in the same transaction and get different results. With repeatable read, that is exactly what that is preventing. 2 reads in the same transaction will always give the same result. Okay. I'm still kind of reordering things in. Question first.
So how does repeatable read work?
How does a repeatable read work?
Yeah, how does it guarantee that you'll get the same read?
It's the simple way to think about it is it makes a snapshot of the table. It doesn't actually do that. That would be expensive. The way that it actually works is through a series of complicated locks. So it's figuring out like which rows do I need to lock and unlock and when.
So it doesn't prevent session 1 from making insertions?
It doesn't prevent session 1 from making insertions, no. So it does have to somehow copy at least this information so that it can repeat it when you try to read it again. Okay, serializable isolation level. So what I have here now is the insert and the select are both trying to happen at the same time. This is the only time that I've shown this, and this is the only time where this will kind of make a big difference. So since they're trying to happen at the same time, and these are with serializable, these are 2 conflicting things. That means one of them is going to win the race and block the other. So if this wins the race, that means that this select will not happen until after session 1 has committed. So you would get, you would get 6 followed by 6. If this one wins the race, then this insert will not happen until session 2 has committed. So you would get 5, 5. So the difference here is that one transaction is blocking or stalling the other, so that whatever you do is consistent with the global state of the database because something has committed by that time. And this is what gives us close to a mutex, but still not actually a mutex. Because you can actually have 2 things inside the transaction at the same time. If they're doing things that don't interfere, then they can both do things. Mutex is purely like, lock this entire region of code, only I can be in. Okay?
So is session 1 prevented from inserting until session 2 commits?
Session 1 is blocked on the insert until session 2 commits. And then the insert will proceed.
So if session 1 happens to go first, then does it get to go until it commits and then session 2 proceeds?
Yes, if session 1 happens to go first, then session 2 is blocked when it tries to read. Yeah.
You said they can both run concurrently as long as they're not trying to modify the same.
Yeah, they can run concurrently as long as whatever they're doing doesn't conflict. This conflicts because this is basically selecting everything from the table or something about the entire table. If this was like insert into X where C equals 1 and this was like select where c equals 10 or something, then they could both proceed.
Oh, so they can even do it as long as it's on the different.
Yep. And it wouldn't be count star. That basically means you have to lock the entire table. Okay, and then so that's isolation levels with transactions, but those are not the best way to do this. This notion of trying to lock things. SQL actually has locks. It has table locks and row locks. We'll talk about Rowlocks, which is this syntax: select whatever for update. That means whatever you selected will be locked if it needs to be locked. So what this is, and then I have, after that tries to happen, then I have delete from x where c equals 1. So this whole thing selects, let's say c is the primary key. So it's selecting one row for update. And then it's going to go and potentially change something in that row. It doesn't actually change anything, but that's irrelevant here. And then delete from x where c equals 1. So what's going to happen is that will be stalled until after the commit, which releases the lock.
When you row lock, does that also prevent other clients from seeing that row, like selecting it?
So when you lock, does it prevent other clients from selecting that row? We'll have that example in a second. Here's another example, though, where the delete is deleting where c equals 0. This can just happen right away because it's a different row. So there's no delay there. What about select? So here's kind of Scott's question. This one selects one row for update. This one selects every row. Does session 1 block session 2? The key is session 2 is not selecting for update. So it just goes right ahead. Now, if session 2 is selecting for update, then it is blocked until the commit. Yeah.
Why is that?
So why is that if they're only both trying to select? The idea is some other transaction, or maybe even this transaction, somewhere in here, might be changing something, where whatever it's changing, it needs the result of that select to be consistent.
Oh, so you're like flagging.
Yeah, you're basically saying I'm going to update this, which means if I ever read a value from it, and I select it for update, then I need that value to be consistent no matter what until I do my change.
So if you didn't explicitly put this inside of a transaction, like at the start transaction,
If I didn't have this,
yeah.
then this one select would be very briefly locked and then immediately unlocked.
The session 2 without the for update is a great condition.
Session 2 without the for update, this one, is a race condition. Depends on whether you care. Like,
Yeah, whether you care.
does this select happen before or after the other select? If it's like you either get the old value or the new value, doesn't matter, then that kind of decides whether it's a...
But you would get different data.
You would get different data based on the order, yes. Notice there's not even a transaction around session 2 in this case. Okay. We talked about testing software when there's a database involved. So basically, the question here is, what are your thoughts on the software engineering of this little piece of code? And this is enough code to critique. So do things, that's some controller. And we want to write unit tests for that controller. Yes?
This makes it very difficult to mock the database.
So what the problem here is, this controller is always just using some new database context with no configurability here. So that means anytime I run this controller, it's going to be running on the live database, assuming that new DB context points to the live database. That means when I write a unit test, it's the live database. When I run the real software, it's the live database. You cannot really do unit testing on the live database because you don't know what state it's in. You don't know what result to check for. You don't know what assertions to write. So what you would do instead is take out this whole using block, because that's creating a new DB context. And what you do somewhere in this class up above is you make a class-wide DB context, which by default can be new DB context, but you would provide another method or constructor or something that lets you change the value of this variable. So then when you're writing unit tests, you make a DB context with a mock database, and then this controller doesn't have to change at all. It just uses whatever that has been set to, whatever that context has been set to. Okay? And that's basically what we did when we were talking about unit testing. Okay, passwords. Is this a valid function to compute the hash for some password? So this is the key derivation function. Ignore salt and pepper for now. This KDF is not using salt and pepper, but is this a valid KDF? Meaning, if I use this to create the hash, can I use it to verify a login at a later time? Yes. So the only thing that's potentially tricky here is this, adding some string to your password, but it's a static string. So when I create the hash, I'm using ABC plus password. When I verify the hash, I'm using ABC plus password. So yes, it is valid. It's not breaking any consistency rules. Okay, what about this? No, this is not valid because I'm going to, at the time of creating the password, I'll get some string prepended to the password, then hashed. At the time of logging in, I'll get some different string prepended and then hashed. So there's no way to verify a hash that was previously computed. Okay, is this a valid method to create a new password salt?
Yes.
Yeah. So, consider this a random number, essentially. You don't know when this is going to be run. It's not a very good random number generator, but, and then, you plus salt. That actually doesn't matter at all. The plus salt is not really helping anything here. But what you would need to do is take that return value and save it into the database somewhere, into some row for that user. So you have to save it, and then this is the only time you use this function is when creating the account. You do not use this function when verifying login because of the randomness of it. When verifying login, you have to pull out the saved salt and then add that to the password before hashing. Okay. So this is a little unspecific. This should say B plus trees more specifically. So we have some table here. We have some primary key on cardinum, and then we're also saying there's a secondary index on just the phone column. And just as with the homework you did, we're ignoring the size of pointers and any other kind of meta information. We have 4K pages, sorry, 4K byte pages. And we want to know what is the branching factor for the phone index. So B plus tree, the internal nodes are going to look like this. You know, they'll have some keys in there, and then in between and to the left and right of, we have pointers. So what is the branching factor? How do we figure this out? What are these? The first thing we need to answer is how many keys are there? How many of these things will fit into an internal node in this index? Scott.
4096 divided by 12.
So 4096 divided by 12?
I think 12. Chart 8 plus 4 for the primary key.
So that would be 8 plus 4, because we have 8 here and 4 here. So do we put the secondary key plus the primary key in the internal nodes?
Oh, sorry, this is internal. No, we don't.
Right, so the only thing that an internal node of a secondary index holds is the key of the secondary index. So the key is just phone. So it's 4096 divided by 8. That's how many keys will fit in a page. And then we have plus 1 for the branching factor, because we have to the left and to the right of the first and last one. That ends up being 513. Okay, how many items fit in the leaf nodes of the phone index? So now what is an item in the leaf node of a secondary index? Here's a leaf node. You know, there's going to be some parent. There's going to be a bunch of leaf nodes. What's the max number of them that will fit? So what we need to know is, what are they actually storing?
Doesn't it store the whole thing?
So doesn't it store the whole thing, which would be 100 plus 8 plus 4. So this is a secondary index. Secondary index doesn't store the whole table row. All it needs to store is the secondary key, which is a phone number, and map it to the primary key, which is a card number. So it'll have a bunch of those. Phone, card num pairs. So how many of those fit into 4096?
341.
4096 divided by 12, 8 plus 4, equals
341.
341. So it's 341 point something, but you don't ever put a partial thing in one page and have it span pages.
So if there wasn't a secondary index, the leaf node would be all 3 elements.
So, next question. How many items fit in the leaf nodes of the primary index? Right? Is that your question?
Yeah.
Yep. So, this is where you have to be aware. Secondary indexes are different from primary indexes. Internal nodes are different from leaf nodes. You just have to be aware of all of those differences. So how many items fit in the leaf nodes? This is the one. This is the clustered index, the primary index. This is where the actual table data is stored. So we're going to have pages again, and these are leaf nodes again. But in the primary index, it has to store the whole row. So it's going to have card num, phone, and name. So we just have 4096 is the page size, divided by 112 is the size of a full row. 100 plus 8 plus 4. And that is, I believe, 36 after taking the floor of the numbers.
So what if the secondary index was just all carved down from name?
If the secondary index was all 3 columns, then the internal nodes, with the keys of the internal nodes would be 112 bytes each, and the leaf nodes would contain that whole combo plus the primary key. I believe that's how it would, it might do something smarter based on, knowing that it doesn't actually have to store the primary key twice. So we will not have an example like that where the secondary index is every single column. Okay, functional dependencies. Given these tables and these functional dependencies, do they hold, given this information? So does the functional dependency SID, comma CID determines grade, does that hold in these tables? Can you determine someone's grade giving a pair of SID and CID? So, for example, 1, 3500. Does that reliably determine the grade A? Yes, that is a unique pair. I guess what I haven't said here is that the primary key in this table is both of those rows. And you don't really actually need to know that to answer this. But yes, that one holds. Does date of birth determine grade? So let's see, we have Hermione with an A. So does 1980 determine A? We have another 1980 and with a C. So Ron is 3, that's why I circled this 3. 1980 does not determine a grade.
Is it also the A minus
Yeah, so that's actually another good point. So this 1980 also has an A minus. That's another violation of this functional dependency. Okay, and then finally, voice code normal form. So this is a different table. I've changed some of the information in here. And what we're saying is we want this functional dependency. We want the course ID to determine grade, meaning everyone in the course gets the same grade. So is this table in voice code normal form? First thing we have to answer is, does this functional dependency hold? In this case, it actually does, because I've changed it. So 3500, all of those students earned a C. 3810, all of those students earned a B. Databases, everyone earns an A. This is fictional. Okay, so the functional dependency holds. Is it in voice code normal form? And I've told you what the primary key is. It's the combo of SID, CID. So it is not in voice code normal form because CID, which is the thing on the left of the functional dependency, CID is not a super key. In other words, if I were to erase some value out of this table, could you predict what was erased, given the rest of the rows and knowing that the functional dependency holds? Yes, all you have to do is go find another instance of 3500 and copy that grade down to there. So to fix it, we need to decompose into two relations. where we just get rid of grade from the enrolled table, and we add a grade mapping table that has CID and grade. And then we just put in 3500 C, 3810 B, 5530 A. And then that's it. Now we have one-to-one information between course and grade, and we're not duplicating a bunch of grades. Okay. So we are, yes, out of time. We will see you for the final. Good luck.